then permutations. And then after that, binary. And then binary distributions, discrete and continuous. And then one parallel simulation of binary distribution. So I hope I'm doing it today. 3 hours. You guys want to? What you're going to do is calculate area that thing inside. You test the y over x. You test the y coordinate of x. And you will plug in that x line and the parabola to test whether the y of the line is more than y, and to test whether the point in the parabola is lesser than the parabola. I will not repeat that for you. We'll just go. But that's how it is to be. That's the individual project. Then can you give me simple functions? Well, we have the square root of x, which will be above the effect. It will be above, because square root of 0.5 is higher than 0.5. So it will be higher than 1. Or this could be the square root of 0.25 is 0.5, so it will be higher than that. We will have a choice between this and that, this. Any other suggestions? I was planning to create a trigonometric function, but look at this. The values of x is not good for it unless I use radius measurement. But it's not good because I wanted to use 1:1. So not the sine function maybe. Y is equal to e raised to x. So I'm not going to use someone guess this. What is e raised to 0? I don't know, right? So it's not possible to not touch the x-axis. So it's a bad idea. Somebody gets this there. So they just need to say what to do with it, but it's possible because it's just like a line. So if you're only dealing with this sign. So it's just like same thing. Is the log? No, it wouldn't pass the x equals to 0 point. So I think the function is correct. Oh, Q. I need to think. It's outside here. It's always more than that. The point is here. It's always lower than that. It's much easier. But what you will get is the area of the outside. So how do you A, B, C, and A, C, D is just the same. I'm not going to take differences between them. Okay, now into the arrangement, but I'm just into the letters like that. Okay. More sugar for me. So right now there's only 20 possibilities. Right, if I take away this thing, just hold this thing for me now, because I'm not going to take the arrangement. A, B, C is the same as C, B, A, A, C is all the same. As long as all those three letters is in there, it's all the same for me. So that's what we call as a combination. That's why in the syllabus they said that a combination is a special case. Permutation is the general case. Combination is a much more specific case. Actually, it's kind of weird to say that. Because when I say that, I'm not considering the arrangement when I say something like that. It's not a general case. I'm saying that permutations is a more general case, it gives you more possibilities. Where combination only gives you less. You can see that from 120 you need to take away something. And the answer would be why is it? Which would be 4 weeks from now, so that would be October. Last week. Since it will be 3 weeks from now, so I give you the assignment, which is 2 weeks from now, so it will be 4 weeks from that day, so it will be 3 weeks from this day, which will pass this. So what I'm saying is that in your project, you only have one function, right? And you are working it together, so I'm hoping that you have an idea where you want to do it. And hence I decided to expand your knowledge on doing Monte Carlo, because we will be using it just to give you a gist of why we are doing this. If you notice, this is what we call a bell curve or a multiple curve case. And the probabilities, the numbers that you see at the back of each group is the area under that curve. And the best way to calculate it is using Monte Carlo. You see that it doesn't really touch. It doesn't touch. So it's asymptotic to the axis. But every time you get a particular range or domain of values, with higher you're getting the area. So we will use Monte Carlo to find it out and to prove that the values in your book is correct. So that's why I want to do this practice on how to do particular areas. Now, this is much harder than your group project, but really not that hard, or it's not like monumentally hard. All you need to do is to choose, which I will give it randomly, to choose between two functions in the board. Actually, you will not choose. I will force you to choose it because it's a random assignment. So once you get the function with you, which is basically giving you two figures, and you're rewarding if you get C and E, whatever you get. So it will kind of look like this. So this is an example of a person getting combination D and C, which is just the same as C and D, which is going to be related to our new lesson today, which is permutation. So we're going to calculate. That's why I'm going to do this. Right? That's my introduction to the world of permutations. Alright, so if you get D and C, it's the same thing as getting C and D. So the the thing that we're going to do is to calculate the area inside of the curve. The one that is below the higher curve and the one that's above the lower curve. So as you can see, the one shaded is the one inside, the intersection area of those two curves. I mean the line and the curve. Is the line and the curve the same? Can I say that the curve is the same? Like y is equals to x, is it a curve? So it looks like I say like f of x is a curve. And f of x is a function, and that line is a function. Does it mean it's a curve? Or not? Maybe just strictly speaking. I'm really asking, I really don't know if it's a curve or a line.
Some books call it straight curve.
Straight curve.
Yeah, it's kind of weird.
Thank you. Straight curve. Alright, so we're going to choose. But before we choose, let us calculate the possibility. How many possibilities can people make from this multiples? The question there is a combinatorics question. Because we don't care on the arrangement of D and C and C and D. But before I go into that, let's go into the simple permutations problem, which I already talked about. So I'll just decrease this and go back here, remove that, and remove it. So I have 3 points with 3 different vectors, A, B, and C. And the problem is, how many possible ways can I put A, B, and C into 2 different vectors? What I mean is, I can only put 1 point inside of that. So what a great student will do is he will list down all the possibilities, which is, of course, likely it's fine. The first possibility, obviously, would be A and B just landing on the 2 different vectors. Another possibility is for maybe B and C landing on the grasses. And another possibility would be A and C landing. But since we consider the other way around, it's just B landing and B landing. So there's another case where the B lands on the first grass and the A lands on the second grass. Same case for that, and same case for this. So the grade 6 students would say, well, there are 6 possible cases of that happening. And that's correct. There are 6 possible cases. And this problem is a permutation problem, which is basically using the idea of factorials, but not entirely the concept of factorials. So if you think about factorials, what they would tell me is 3 factorial. But one side, which is correct, 3 factorial gives you 6. But you will see that it will not be useful when I increase the number of classes or I increase the number of coils. It won't be answering. So we will see that. So let's try. Let's increase the number of coils. And let's do it manually. So just guide me with the possible ways this can happen. So A and B, B and C, C and D, A and D, and just flip it all around. Is there anything? Oh, there's another one, right?
B and D.
B and D. B and D. B and D, and one more.
A and C.
A and C, right. Yeah, A and C, because I don't have any A and C. Some other students, what they do is they don't get confused is use A first and try all the possible equations. One of the books I've seen before was use A and put lines on this. And B, but I can't use A anymore. C and D, and then C is just means 1, 2, 3, 4, 5, 6, which is much better than that. And then you just multiply it by 2, so you just keep it down. C and D, E and C, D and A, B and B, C and D. So those are all the possible. And that's 12 of them. But you see that the factorial doesn't work out. 4 factorial is not. It's 24, so it's not 12. So it doesn't work out. So it's not the simplest factorial. I know that you know the formula. The NPR is shortcut. NPR, right? NPR in calculation. The shortcut is, I mean, if you don't want to just suddenly derive a formula, just to really understand why it is like that. What it's trying to tell you is if you have only 2 things where you put it into, then if you have 4 coins, then the first glass can have A, B, or C, or D. So there's 4 possible coins that can get inside the glass A. So there's 4 possible coins you can put in there because you can use all of them. But once one of them lands on the first glass, you already remove one possibility from the 4. So now there's only 3 of them. So there's only 3 things here. But what did we learn from probability way back then? From the definitions of B given A. And what is that equal to? That's equal to the intersection of the 2 over B. And if you try to relocate the PA, what you get is, I'll just put this on the other side so it's much easier to see. Alright. And is putting the coin in these 2 glass dependent? No, they don't depend on each other. If one coin would fall down, it wouldn't control the other one falling down, so they're not dependent. So what happens is that B given A becomes PB. Since these events are independent, this thing becomes PB. So you can see that the probability of the intersection is just multiplying the probability PA times PB. But what is PA times PB? It's the number of events of A over the total number of events times the number of events of B over the total number of events. Right? And then we have this, which is just equal to we just raise it, number of events in the intersection over NG. So if I multiply this into the NU squared and move it to the other side, and that cancels out, and we have an NU times A to section B times NA times NB. This is your permutation, and this is how you do the permutation. You multiply event A with event B. That's the reason why we're multiplying it. And when you multiply, which is this times that, this is what we call a permutation. That will become the answer to this problem. And that's exactly what we have in the calculator, which is NPR. This is NPR.